Hi everyone, welcome to Mash Math. Today we are going to study chapter 6 Triangles, Theorem 6.1. Very important theorem. It is known as Basic Proportionality Theorem. In short, Bpt Theorem or Thales Theorem. Since it is used by Thales, so we call it Thales Theorem. Okay. So what does this theorem says? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So what they are trying to tell is, if the line is drawn parallel to one side of a triangle. So here is a triangle ABC. If a line is drawn parallel to one side of the triangle, any of this side we can take. Since here our base is BC, so parallel to BC will draw one line. Okay, let's draw parallel to BC one line here. Okay, and we can name it this D and E. Okay, so if a line is drawn parallel to one side of the triangle to intersect the other two sides, this line will intersect these two sides, right? I can highlight it. This side. These are the other two sides. Okay. So this line DE is intersecting the other two sides. Okay, intersect the other two sides in a distinct points. So distinct point is intersecting, making this side, this line is making this side and this side into two parts. So at different point, that is D and E, at this point and at this point, this side AB side is made into two parts, AC side is made into two parts. Okay, the other two points, the other two sides are divided in the same ratio. So in short, what they are trying to tell, or what this theorem is trying to tell is, if any one side of the triangle, if we draw a parallel line, this parallel line will divide these two sides of the triangle into equal ratio or same ratio, meaning to say this side will be equal to this side and this side will be equal to this side, that is AD upon DB will be equal to AE upon EC. So that is a ratio. So let's be now what we have to prove is, yes, it is true that this parallel line is dividing these two sides into two equal ratios. That only we have to prove. So I hope you are understanding. So what is given to us? What is given to us is BC and DE is parallel. Okay, what is given is BC is parallel to DE. So that is given. What we have to prove is that this side of this line is dividing this side and this side into equal ratio, meaning to say AD upon DB, AD upon DB, DB is equal to AE upon EC. So this is what we have to prove, that this line is dividing this side and this side into equal ratio. So this upon this side upon this side are equal. So now in this theorem we have to remember there is a construction. So we have to do some construction. So what we will do, we join B with E. Okay. And then join C with D. So this is the construction we are doing. And then we have to draw a perpendicular line. For AD, we will draw one perpendicular line from E. So this I will do it with the red color. So from E, we are drawing one perpendicular line for AD. Means it should be okay. So this is perpendicular and this is base and this is perpendicular. I hope you are understanding. If this is AD means this is E. So we are drawing a straight perpendicular line which will give us 90 degree. So this becomes 90 degree. Okay, both sides. So same way we have to draw from D for AE perpendicular line. So that is a perpendicular. AE becomes base and this becomes a perpendicular line, then becomes 90 degree. Okay, so this is the construction we are doing. So we can write down join B with E and C with D. Okay, then for AD we are drawing a perpendicular line E. You can name it this M and this is as N. Okay, you can write for AD perpendicular line is EM and for AE perpendicular line is DN. Okay, this is the construction we have done it. So now we have to prove that this is what we have to prove, that AD upon DB is equal to AE upon EC. Okay, so let's begin now proof. So first of all, to prove we have to understand one thing, that area of the triangle we are going to calculate. So area of the triangle meaning is what? That you have to understand. Once again, so when we have to calculate the area of the triangle, what we do, for example, this is a triangle, okay, triangle ABC. When we want to calculate the area of this triangle, what we do, formula is what? Actually area of the triangle, half into base into height. Okay, that's the formula to calculate the area of the triangle. So here half we keep as it is. Now base is what here? Base is BC. Okay, and height is where? Height we don't have. So what we do, we draw a perpendicular line. For base, perpendicular line we draw. So then you can name it this O. Okay, then AO becomes a height. So AO. Understand? If the triangle is this direction, okay, if the triangle is this direction, I'll just draw properly. Let me show like this. Okay, this triangle is like this. Here it has no height. Okay, let's take this is PQR. For this triangle, if you have to calculate the area of the triangle, area you know, half into base into height. Now half we know, base we know, that is QR is the base, but here there is no height. So what we do, for base we will draw height from here. Okay, from here we will draw the height. You understand? So if the triangle, if this triangle has no height, then we take it from the outside also we can calculate the height. Understand? So this is very important for to study. So first let us calculate the area of the triangle. We begin from here. So start from here. So AD. We have AD here. So let's see where is AD. AD is here. So let's take this triangle. That is ADE. Okay. For calculating the area of the triangle. Area of triangle ADE. ADE. Okay. For that, area of the triangle is what? Half into base into height we have to calculate. Okay. So now what is half? We keep as it is. Base is for ADE. I'll just highlight it for this triangle. Okay. For this triangle, base is AD. If base is AD, so we'll write down base is AD. So base is AD means then height is what? If this is base, then 90 degrees here. So height will be EM. Okay. I hope it is clear to you. Similarly, we will find out the area of triangle this side, because we have to prove this side, that AD upon DB we have taken, right? So we will take, first we finish this AD. Now let's go for DB. So DB is this side. So let's take this type of triangle, this side of the triangle. So this triangle, just highlight it. Okay, this triangle. Okay, now this triangle will find out the area. So same way, area of triangle DBE. DBE. Also same way, formula remains the same, half into base into height. So half into, now base. What is the base for this? If this is the case, base is this DB. Okay, so DB into height is what? Now for this height is not that there is no perpendicular for this. I told you, if the triangle has no perpendicular, we can take it from outside the perpendicular, the height. So for this triangle, if you see, this is the base. So that means here only the perpendicular will be, we can be drawn. So like this, no? Base is here. So here the perpendicular is drawn. So this is the base. So then this becomes the height for this triangle. Okay. So this is what? EM. Okay. So now let's write the ratio of this triangle. So area of triangle ADE upon area of triangle DBE will be equal to, this is half into AD into EM upon, and this half into DB into EM. So what we get? Half get cancelled, EM gets cancelled. So what we are left with? Area of triangle ADE upon area of triangle DBE is equal to AD upon DB. This we keep as equation 1. Is it clear? So we have finished one side, AD upon DB. Okay. So now next. So next we have to take AE. Where is AE? AE is here. If this is AE, this becomes base, means then height becomes this blue line. Okay, DN. Okay, this is base, means this becomes a height. So let's take this triangle AED. Okay, so area of triangle AED equal to half into base into height. So here also half. Base is what? AE is our base. AE. Height becomes, I told you, this blue line for this base. This becomes the perpendicular line height. So DN. Now same way for area of triangle. Now we have done. So this side we have to see. So we will take this triangle. This triangle. Okay. That is triangle DEC. DEC. So same formula only. So half into base is what for this triangle? Base. We have taken this side. So base becomes EC. EC. And then height. So for this also, like similarly, this triangle also has no height. So we take it outside. So if this is the base is extended, and this becomes the height of this triangle. You see, this triangle is like this. So for this triangle, the height is this blue color, as I showed you. Okay. So that is DN. So now let's write the ratio. area of triangle AED upon area of triangle DEC equal to, this is half into AE into DN upon half into EC into DN. So both get cancelled. This gets cancelled. So area of triangle AED upon area of triangle DEC is equal to AE upon EC. So this is our equation 2. So let's keep it this one side. So look at here again. Look at this yellow color triangle and this green color triangle. Okay. So if you see area of these two triangle, area of triangle, this is yellow color is DBE. DBE will be equal to this green color triangle, area of triangle DEC. Why this area and this area will be equal? Because there is a property. If you see DE and BC both are parallel line. So between this parallel line, these two triangles are formed. So between these two parallel line, when two triangles are formed, and also both the triangle base is DE. So DE becomes a base for this yellow color also, and for green color also the base is D, common. This is common base for this yellow color triangle also and for green color triangle also. So therefore there is a property that if two triangles are formed between two parallel lines and having the same base, then their area will be equal. So that is the property. So you can mention here that having the same base, the two triangles having same base and between parallel line will have areas same. Okay, so they will have their area same. That's why I wrote this triangle will be equal to this triangle. So now from equation 2, our equation 2 is what? Area of triangle AED is equal upon area of triangle DEC, right? So now here you see DEC is equal to DBE. So instead of DEC, can we write DBE? So let's write down this area of triangle AED upon area of triangle. Instead of DEC, we'll write DBE, because you see their areas are equal. So both the areas are equal only. So whether you write DBE or DEC, anyone, because both are same. So instead of that, we have written this. So upon equal to, here what is written? AE upon EC. AE upon EC. This is our equation 3. Okay. Now look at equation 1 and 3. Okay. From equation 1 and 3. Okay. Equation 1 is what? Area of triangle ADE upon DBE. Equation 3 also just look at. 1 is ADE upon DBE. 3 also is ADE upon DBE. So that means both equation 1 and equation 2, left side is the same, this side is same, here also same. So if both the side left side is same, then right side also will be equal to each other. So if this is equal to this, the same thing is equal to this, then these two in turn will be equal. So therefore AD upon DB will be equal to AE upon EC. So have we proved this? You see, AD upon DB is equal to AE upon EC. AD upon DB equal to AE upon EC. Hence, proved. So this is how you have to do the theorem. It's very easy. Once you understand this, then it is very easy for you to write. That's it. Thank you. God bless you.